In this video, we're going to look at confidence intervals for difference between parameters. So difference between means or difference between proportion. Difference between mean will be mean 1 times mean 1 minus mean 2, or proportion will be proportion minus another proportion. So we want to find confidence interval for difference between two parameters. So there are three types, and we'll look at each type closely, but I think it will be useful to look at formula sheet because formula sheet does organize stuff, this materials very well. Here we're looking at two samples. We have data from two samples, and we can find confidence interval for difference between, that's what subtraction means, subtracting two means, or difference between two proportions, subtracting two proportions. And within mean, there's two types when population standard deviation are known and when population standard deviations are unknown. And depending on that, we use either Z or T. And that's very similar to the one sample we did earlier video. And for proportion, there's only one formula. So we're doing three different types of problem in this video. So important thing is you recognize if the population standard deviation is given and not given in a mean problem. So first, let's look at finding confidence interval for difference between population means. So we're dealing with mean 1 and mean 2, two population means. When, very important, when population standard deviations is known, or we should say are known, since we have two of them. Okay. So notation, sigma 1 and sigma 2 are population standard deviation from population 1 and 2. Sample mean 1, x bar 1, sample x bar 2 means sample mean 2. And n1, n2 is sample size for corresponding population 1 and 2. And point estimate is difference between two sample means. So from the two sample mean, we subtract each other. In terms of which one is group 1, group 2, that's something we can decide. As long as you keep it consistent, which one is group 1, group 2, the answer, the conclusion will be same. And it's okay to have a negative point estimate. Yeah, something to keep in mind. So margin of error, again, these formulas are provided. Margin of error, we use Z of C, critical value, Z of C times square root of population standard deviation 1 square over n1 plus population standard deviation 2 square over n2. And confidence interval, same pattern, but now this is a point estimate. From point estimate, we subtract, add margin of error to estimate difference between population mean. So I can do a quick picture to understand what's going on here. We have a one population and another population, two population. We want to know difference between these two population means, mean values. So what we do is we sample them. Here's sample 1, and we sample here also, of course, with simple random, two sample. And from two samples, we're finding the difference, and then from the difference, we add and subtract margin of error. So let's look at an example to demonstrate this problem. Again, when you read a problem, it's important to recognize what it is the problem is asking. Suppose you're studying fishing data from Yellowstone stream before and after a fire. Before and after a fire. Fishing reports include number of trouts per day per fisherman. A random sample of 167 reports before, so this is before the group, fire showed the mean catch was 5.2 trout, and assume the population standard deviation of this data before the fire is 1.9. Another random sample of 125 fishing report 5 years after the fire. So the mean catch per day was 6.8. Population standard deviation was 2.3. Compute 95% confidence interval for difference of population means. Erase that. Difference in population means. So reading this problem, we need to be able to recognize that we're doing one of these two. But because popular standard deviation is known, we're using this formula to find margin of error. So let's find this. For these kind of problem, it's important to organize the data very well. So we have group one, let's call it just one. Group one, the sample size N1, this is before the fire, group one, N1 is 167. And sample mean was 5.2, and population standard deviation was 1.9. And for group two, after fire, 5 years, after the fire, the sample size was 125. Sample mean was 6.8. Population standard deviation is 2.3. So organize the data. Okay. So now that we're organized, let's actually solve this problem. Always find the point estimate first. Well, this is asking difference of population means. So point estimate is difference in sample mean. Sample mean minus sample mean 1 minus sample mean 2. In this case, 5.2 minus 6.8, which gives us negative 1.6. So negative just means that the second group had a larger value. Okay. So it might not make sense in terms of context of this problem if we just think about one sample mean of negative. It doesn't make sense a negative length of a trout, right? But here we're comparing two values. So negative means the second group after fire had a longer length of trout, right? For just the sample mean. Okay. So then let's find the margin of error. Margin error formula, we're using this one right here. So let me write that down. Z of C times square root of population standard deviation from the first group square over sample size N1 and population standard deviation second group divided by N2. Okay. It said 95%. Therefore, this value we can find it was for 95% confidence interval. So that value let's find from the table right here. Z 95 is 1.96. 1.96. So critical value is 1.96. So let me just write here 1.96. 1.96 is the critical value. Multiply by square root of sigma 1. Oh, I forgot to write 1 here. 2 here. It's 1.9. Square divided by N1 is 167. Plus 2.3 square divided by 125. I'm just copying numbers from here, from the problem. And let's round to 4 decimal place. Here, margin of error is 0.4955. 4955 is the margin of error. So for confidence interval is point estimate, which is difference between two sample means minus margin of error, tells us difference between population means, and point estimate difference plus margin of error. Well, we know these values. Let me write these down. We know this value already, negative 0.16. Negative 0.16 minus margin of error. Minus margin of error right here, 0.4955. and margin of error. Now we add to the point estimate 0.4955. So let me write the final answer, the bottom right here. Confidence interval is negative 2.0995, negative 1.1045. So this means we are 95% confident that the difference in population mean is between negative 2.0995 and negative 1.045. So the structure is very similar in all these confidence interval problems. We always find the point estimate, find the margin of error, and add and subtract margin of error. And interpreting confidence interval is very similar. We're 95% confident that population mean, difference in population mean is between these two numbers. So next, let's look at finding confidence interval for population mean when population standard deviation are unknown. They're unknown. So just like the one sample mean, one population mean estimation, we use student t distribution, t table. So let me go to the formula sheet. Here we're at here right now. Population, both of them are unknown. So this right here. So we need to use sample standard deviation instead of population standard deviation. S1 and S2, that's what they're referring to. And all other values are the same. X bar 1, X bar 2 refers to a corresponding sample means, and M1 and N2 means sample size. Point estimate is the same. Now margin of error, we have to use critical value, T critical value. So when we use T table though, we're going to have 2 degrees of freedom. We use smaller of them, smaller one. That's the rule. We always use a smaller one when we find the T value. So let's look at this example. Again, as I read the problem, try to identify what kind of problem this is. Suppose a random sample of 29 college students are randomly divided into 2 groups. The first group of 15 people was given 0.4 liter red wine before going to sleep. Second group of 14 people was given no alcohol before going to sleep. Everyone, both groups went to sleep at 11 p.m. The average brainwave activity was determined for each group in the groups. Assume the average wave distribution in each group is bell-shaped and symmetric. So it's very close to normal. That's what they're telling us. The first group had mean of 19.65 and standard deviation of 1.86. So here we have to be careful. Here they're giving a sample mean because from the first sample of 15 people, we got mean of 19.65, and from 15 people of sample, we got standard deviation of 1.86. So standard deviation they're referring here is sample standard deviation. Similarly, in the second group, had sample mean of 6.59 and standard deviation of 1.91. Although they don't use the word sample and sample here in front of the standard deviation and the mean, it is implied that because it's from the second group of 14 people. So this is sample standard deviation. So in the problem, population standard deviation not given. Compute a 90% confidence interval for the difference between means. So this is the key word. Find the confidence interval for difference between 2 population means. Okay, so that's how we know that this is a difference problem. So just like earlier, let's organize the data. So group one, given wine. Right? Group one. So group one sample mean was 6.59. Standard deviation. Now we have to write S because it's sample standard deviation. Sample standard deviation of 1.91. And sample size was 15 people. Oh, I switched the color. Let me fix that. I underlined the red for. So let me fix it real quick. So here are the organized data to group 1 with wine, group 2 with no wine or no alcohol. Okay, so once we have organized, let's find point estimate first. Point estimate, let's just call it PE. Point estimate is first sample mean minus second sample mean. In this case, 19.65 minus 6.59. Then we get 13.06. So this is the sample difference. So from here, we add and subtract margin of error. Margin of error is T of C times square root. Again, this formula you don't need to memorize. You need to know when to use them. This is the formula. So let's find the critical value first. Let's find this first. Well, it says degrees of freedom. Well, it's 0.9. That's the confidence level. Degrees of freedom, we have two of them, N1 minus 1, N2 minus 1. Well, N1 is 15, so this gives 14. N2 is 14, so this gives us 13. So since we have two, we use smaller one. Unless they're same, sometimes they could be same 2 degrees of freedom, then just, they're same, we can use either one. But here we use a smaller one, so this is the degrees of freedom we use. So when we go to the T table, we look at 0.9 and 13. So let me go to the T table. 0.9 and 13. 13 is right here, and 0.9 is 1.771. So we use this one for critical value. 1.771. So this right here is 1.771 is the critical value. And all other value, we already found it given the problem standard deviation. So let me copy these numbers. Calculate this in your calculator. You get 1.2412. That's the margin of error. So for confidence interval, again, we follow the similar format. Confidence interval is point estimate, which is difference between sample mean, minus margin of error, difference between sample mean plus margin of error. But we already know this value, which is 1306. So 1306 minus 1.2412. plus 1.2412. So if you calculate that, you get 11.811. Oops, 11.8188. This one you get 14.3012. So this is the confidence interval. So let me write down the conclusion in a sentence, and we've been talking about it a lot. This means we are 90% confident that difference, we're looking at difference in population mean, is between these two numbers, 11.811 and 14.3012. So key point is we're using T table for the critical value, and we use smaller degrees of freedom. Smaller up to. So lastly, let's look at confidence intervals for difference between population proportions. So here, we looked at these two now. We look at confidence interval for difference between population proportion. That's what P is representing, proportion. So we're using this formula. We use this formula to find the margin of error. And I'll go over what all these things are. X1, X2 are number of individuals from group 1, group 2, sample size from group 1, group 2, proportion from group 1, group 2, population proportion. Now, P hat is sample proportion from group 1, group 2. So difference between sample proportion gives us point estimate. From here, we subtract and add margin of error. This is the margin of error formula in confidence interval. So let's just look at a problem so I can demonstrate this example. Suppose that two groups of subjects were randomly chosen for a sleep study. In group one, before going to sleep, the subjects spent 1 hour watching comedy movie. In this group, total of 175 dreams were recorded, of which 49 were dreams with feelings of anxiety, fear, or aggression. In group two, however, the subject did not watch a movie but simply went to sleep. In this group, total of 180 dreams were recorded, of which 63 dreams were of feelings of anxiety, fear, aggression. Compute 95% confidence interval for difference in proportions. Since the problem says difference in proportion, that's how we recognize we're looking at this formula to find margin of error. So first, let's organize this data. So group one, movie. They watched the movie, comedy movie. Well, sample size was 175. And here, if you go to the formula again, this x is referring to, in this case, 49, because we're comparing between people, proportionally people who had dreams about feelings of anxiety, fear, or aggression, right? So x1 here is referring to 49. Group 2 is no movie. Sample size was 180. And x2 in this case, how many had a dream? Yeah, 63 of them had a dream about anxiety feeling. Okay. So knowing this, let's find point estimate first. Point estimate. Point estimate is p hat 1 minus p hat 2. So essentially, difference between sample proportion. Well, p hat 1 is 49 divided by 175 from here. Out of 49, out of 175, total of 49 had that dream of feeling aggression, fear, anxiety. P hat 2 will be 63 out of 180. So we just subtract these two values. 49, 175 minus 68 over 180. Sorry, I meant to write 63. Then this should give us negative 0.07. So this is the point estimate. From here, we add and subtract margin of error. So let's find the margin of error. Margin of error is z of c, critical value, times square root of p hat 1 times 1 minus p hat 1 divided by sample size 1 plus p hat 2, 1 minus p hat 2 divided by sample size 2. Square root entire thing, then multiply. So let's find critical value. Well, we're doing 0.95, 95%. So from this table, 95 is 1.96. So this value is 1.96. So 1.96 multiplied by square root of p hat 1 was 49 over 175 multiplied by 1 minus 49 over 175 over sample size was 175 plus 40, oops, sorry. Now p hat 2, right here, p hat 2 is this, 63 over 180 times 1 minus 63 over 180 over 180. So when you put this in a calculator, just do one at a time. Do this times this, divide by 175, write this number down, find this number, write it down, add them, and take the square root, and then multiply to 1.96. 0.96. So this should give us margin of error of 0.0963. It's the margin of error. So for confidence interval, is point estimate, which is p hat 1 minus p hat 2, minus margin of error, gives us difference between population proportion, point estimate, difference between sample proportion, plus margin of error. And we know we already calculated this value. That's why we always find the point estimate first. Point estimate we can think as that's the beginning value we start estimating. This is the beginning value. That's why it's called an estimate. And the reason it's called point estimate because it's 1 point. This is one number. From this one number, we subtract, add margin of error. Margin of error, which is this. So it will be negative 0.07 minus margin of error. P1 minus P2. Negative 0.07 plus margin of error. So just some numbers. I get negative 0.166 P1 minus P2, 0.026. So this is our final answer in terms of confidence interval. Again, it's important to know what's the meaning. So let me write down the meaning here. This means we're 95% confident that the difference in population proportion is between these two numbers, lower bound, upper bound. We're 95% confident that the difference in context of this problem is the proportion of having a dream with feelings of anxiety, fear, aggression. So we're 95% confident the difference in proportion, population proportion of people who had dreams of anxiety, fear, and aggression, their proportion, difference in the proportion is between negative 0.166 and 0.026. And it's okay to take anything of negative because we're finding the difference. That means one is bigger than the other. So let's summarize this video. Here we looked at 3 types of problem for 2 samples. The basic structure is similar from one sample. It's just that you have to identify the wording of difference in the problem. And in the problem, we also have giving a two samples. So for mean, it will deal with the 2 sample means, and proportion will deal with two sample proportions. And point estimate is difference between sample mean for population mean. Point estimate for population proportion is difference between sample proportions. And here's a formula for margin of error. You don't need to memorize these, and make sure to use correct critical value for Z. Here and here we use this table. For T we use T table, and for here it's because we'll have 2 different degrees of freedom, 2 separate degrees of freedom from 2 sample sizes. We use a smaller one.